Hello everyone, my name is Apurva Kapil and I'm working as an assistant professor at the Department of Computer Engineering in Silver Oak University. The outline which will be covered in today's session are exploratory data analysis, which is also known as EDA process, data visualization, and how to choose right data visualization. Talking about EDA, it is a process used for investigating our data to discover patterns, anomalies, relationships, or trends using statistical summaries and visual methods. It is essential for understanding the data's underlying structure and characteristics before applying more formal statistical or machine learning methods. Some key points that we should normally check in the EDA process are mentioned here. Distribution of data, missing values, outliners, correlations, patterns and trends, group comparison, data type assessment, data quality assessment, and visual exploration. Let's try to understand them one by one. Talking about distribution of data. Assessing the distribution of data using histogram, box plots, and summary statistics helps understand the central tendency and variability. Second is missing values. Identifying and addressing missing data is crucial as it can significantly affect analysis. Techniques include imputation, deletion, or understanding the reasons for missingness. The third we have is outliners. Detecting and examining outliners to understand their impact on the data set and deciding how to handle them. For example, removal of transformation. The next we have is correlations. Analyzing correlations between variables using correlation coefficient and scatter plots to identify relationship and potential dependencies. The next we have is pattern and trends. Looking for patterns, trends, or anomalies in the data which can be visualized using line graphs, bar charts, or time series analysis. Group comparisons. Comparing matrix across different groups, for example, categories or time periods to identify significant differences or similarities. The next we have is data type assessment. Understanding the types of data, numerical, categorical, ordinal, and their appropriate element in analysis. Data quality assessment. Evaluating data quality to identify errors or inconsistencies that may need correction. Visual exploration. Employing various visualization tools like heat map, pair plots to understand complex relationship in the data. Now, we will look into the types of EDA. Depending on the number of columns we are analyzing, we can divide EDA into two types. EDA or exploratory data analysis refer back to the method of analyzing information units to uncover styles, pick out relationships, and gain insights. There are various sorts of EDA strategies that can be hired relying on the nature of the record and desire of the evaluation. Here are some unusual kinds of EDA. First is univariate analysis. This sort of evaluation makes a specialty of analyzing character variables inside the record set. It involves summarizing and visualizing an unvaried variable at a time to understand its distribution, relevant tendency, unfold, and different applicable records. Techniques like histogram, field plots, bar charts, and precise information are generally used in univariate analysis. The next we have is bivariate. Bivariate analysis evaluation involves exploring and connection between variables. It enables find association, correlation and dependencies between pair of variables. Scatter plots, line plots, correlation matrix and move tabulations are generally used strategies in bivariate analysis. Next we talk about multivariate analysis. Multivariate analysis extends bivariate evaluation to encompass greater than variables. Its ambition is to apprehend the complex interactions and dependency among more than one variable in a record set. Techniques inclusively of heat maps, parallel coordinations, aspects analysis and primary component analysis are used for multivariate analysis. Let's understand what is data visualization. The representation of information in the form of a chart, diagram, picture, etc. is known as data visualization. The right data visualization can make a huge difference in how effectively you communicate your data insights. Choosing the wrong visualization can lead to confusion and misinterpretation, while the right one can help us to quickly and easily understand the key takeaways. Now the question arises, how do you choose the right data visualization? It starts with understanding your data and you want to communicate. Data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliners, and patterns in data. Additionally, it provides us an excellent way for employees or businesses owner to present data to non-technical audience without confusion. In the world of big data, data visualization tools and technologies are essential to analyze massive amount of information and make data-driven decisions. Now, what are the advantages and disadvantages of data visualization? Something as simple as presenting data in graphic format may seem to have no downsides, but sometimes data can be misrepresented or misinterpreted when placed in the wrong style of data visualization. When choosing to create a data visualization, it's best to keep both the advantages and disadvantages in mind. Advantages. Our eyes are drawn to colors and patterns. We love quickly identifying red from blue and squares from circles. Our culture is visual, including everything from art and advertisement to TV and movies. Data visualization is another form of visual art that grabs our interest and keeps our eyes on the message. When we see a chart, we can see something, we internalize it quickly. It's a storytelling with a purpose. If you have ever started a massive spreadsheet of data and couldn't see a trend, you must know how more effective a visualization can be. Some other advantages of data visualization includes easy sharing information, interactively explore opportunities, and visual patterns and relationships. Now, what are the disadvantages of data visualization? While there are many advantages, some of the disadvantages may seem less obvious. For example, when viewing a visualization with many different data points, it's easy to make an inaccurate assumption. Or sometimes the visualization is just designed wrong so that it's based on confusion. Some other disadvantages include biased or inaccurate information. Correlation doesn't always mean caution. Core messages can be lost in translation. Why data visualization is important? The importance of data visualization is simple. It helps people see, interact with, and better understand data. Whether simple or complex, the right visualization can bring everyone on the same page regardless of their level of expertise. It's hard to think of a professional industry that doesn't benefit from making data understandable. Every STEM field benefits from understanding data, and so do fields in government, finance, marketing, history, consumer goods, service industries, education, sports, and so on. Now, let's understand what is plotting and visualization. Plotting or data visualization is the first step for quantifying the relationship between feature and target variables. A good data visualization has several essential components such as data component, geometric component, mapping component, scale component, label component, and ethical component. Now, let's understand how to choose right data visualization. Data visualization are a vital component of a data analysis, as they have the capability of summarizing large amounts of data efficiently in a graphical format. There are many chart types available, each with its own strength and use cases. One of the trickiest parts of analysis process is choosing the right way to represent your data using one of the visualization. Common rules for data visualization should include showing change over time, showing a path to whole composition, looking to how data is distributed, comparing values between groups, observing relationship between variables, and looking at a geographical data. The types of variables you are analyzing, the audience for the visualization can also affect which chart which works the best within each role. Certain visualizations can also be used for multiple purposes depending on these factors. Let us look into the data visualization techniques which we can use in for presenting different solutions of the data. It is important to keep in mind that you don't always need to use chart for your data. Sometimes just showing the data as text is the most important way of conveying information. A single value chart displays a single record from a search in order to make the value stand out at a glance. Single value data that can serve as indicators of the current performance. In this quite widespread cases, plotting each value on a separate chart often makes sense. That is where Gauss and bullet charts come into play. Bullet chart is great for comparing quantitative data against qualitative data, such as profit or loss against good or bad. A table chart is a mean of arranging data in rows and columns. The use of table is perceptive thought or communication, research and data analysis. Table appears in print media, handwritten notes, computer software, architecture, augmentation, traffic signals, and many other places. Next, talking about charts for showing change over time. One of the most important applications for visualizing data is to see the change in numeric value for a feature or metric across time. These charts usually have time on the horizontal axis moving from left to right with the variable of interest values on the vertical axis. A line chart, also known as a line graph or a curve chart, is a graphical representation used to display data points connected by straight lines. A sparkline is a tiny chart in a worksheet shell that provides a visual representation of data. A connected scatter plot displays the evolution of numeric variables. Data points are represented by a dot and connected by straight line segment. It often shows a trend in data over intervals of time. A time series, a diagram that shows narrow bands of different heights to show different amounts so that they can be compared. A box plot is a chart that shows data from 5 number summary including the number of measures of central tendency. Now let's talk about charts showing part to whole composition. Sometimes we need to know not just the whole but the component that comprises the total, while other charts like a bar chart can be used to compare the values of the component. The following charts put the part to whole decomposition at the front. The first one we have is a pie chart. It is a type of graph representing data in a circular form, with each slice of the circle representing a fraction or proportionate part of the whole. Next we have is a donut chart. Donut chart shows each cell data as a slice of a donut. That chart may contain one or more donuts arranged one side of the other. Each donut shows a series of data. Next we have is a waffle chart or a grid plot. A waffle chart is essentially a square grid where each cell represents a portion of percentage of the whole. These charts are great for displaying proportions like election results or the composition of a population. Next we have is a stacked bar chart. It is a type of bar chart that portrays the composition and comparison of several variables through time. Stack charts usually represents a series of bars or columns stacked on top of one another. They are widely used to effectively portray comparisons of total values and across several categories. Next we have is charts for how data is distributed. One important use for visualization is to show how data points values are distributed. A histogram is a type of chart that shows the frequency distribution of data points across a continuous range of numerical values. The values are grouped into bin or buckets that are arranged in consecutive orders along with horizontal x-axis at the bottom of the chart. A density curve is an idealized representation of distribution in which the area under the curve is defined to be 1. Density curves need not to be normal, but the normal density curve will be the most useful to us. Letter value plots are a variation of box plots that replaces the whiskers. The values within the largest data depths within the fence with a variable number of letter values selected based on the uncertainty associated with each estimate and hence on the number of observation. A violin plot is a hybrid of box plot and a kernel density plot which shows peak in the data. It uses to visualize the distribution of numerical data. Now, of course, one of the best way to understand the visualization is to see it. What a crazy concept with public data visualization, galleries and data everywhere online. It can be overwhelming to know where to start. So, we have different type of visualization. When you think of data visualization, your first thought probably immediately goes to simple bar graphs or pie charts. While these may be an integral part of visualization data and a common baseline for many data graphics, the right visualization must be paired with the right set of information. There's a whole selection of visualization methods to present data in effective and interesting way. Let's look into some general types of visualization. We have chart, we have table, graph, geospatial, infographic and dashboards. Let's understand them one by one. Talking about chart, information presented in a tabular graphical form with data displayed along two axes can be in the form of a graph, diagram or a map. Talking about table, a set of figures displayed in rows and column is known as a table. Whereas graph is stated as a diagram of points, lines, segments, curves or areas that represents certain variables in comparison to each other, usually along two axes at a right angle. Next we have is geospatial, a visualization that shows what the data in map form using different shapes and colors to show the relationship between pieces of data and specific location. Infographic, a combination of visual and words that represent data, usually uses charts or diagrams. Dashboards, a collection of visualization and data displayed in one place to help with analyzing and representing data. Let's get into some more specific examples of data visualization. The first we have is area map. A form of geospatial visualization, area maps are used to show specific values set over a map of a country, state, county or any other geographic location. Two common types of area maps are choropleths and isopeths. The next we have is bar charts. Bar charts represent numerical values compared to each other. The length of the bar represents the value of each variable. The next we have is box and whisker plots. B shows a selection of ranges. The box across a set measures the bar. Next we have is a bullet graph. A bar marked against a background to show process or performance against a goal denoted by a line on the graph. Then we have is a Gantt chart. Typically used in project management, Gantt charts are a bar chart depiction of timeless and task. Heat maps, a type of geospatial visualization in map form which displays specific data values as a different color. This doesn't need to be temperatures, but that is a common use. Highlight tables, a form of table that uses colors to categorize similar data, allowing the viewer to read it more easily and intuitively. Next we have is a histogram, a type of bar chart that splits a continuous measure into different bins to help analyze the distribution. Pie chart is a circular chart with triangular segments that shows data as a percentage of a whole. Tree map, a type of chart that shows different related values in the form of tree. The tree map functions as a visualization composed of nested triangles. These rectangles represent certain categories within a selected dimension and are ordered in a hierarchy or tree. Quantities and patterns can be compared and displayed in a chart space. Tree maps represent the part of whole relationships. Now, how can we read a tree map? Tree map is an accessible way for viewers to interpret their data at a glance. Color can represent dimensions such as categories or measures. If used to represent a KPI, a darker color may highlight extremes, high or low. For dimensions, a user might use a categorical palette assigning a different color for each available shipping mode. For measures, a continuous color palette would show a company's sale, profit or loss. When analyzing a tree map for insights, the largest box shows the largest part of the whole, while the smallest box shows the smallest part. For a deeper analysis, these boxes can be nested to show many categories. For example, a box within the office expense dataset might display percentage spent on the furniture. A box nested within that box might display percentage spent on that. Now, when and how to use tree maps for visual analysis. Tree maps are helpful when visualizing a large number of related categories. If specific value should be displayed, a bar chart may be a better choice. A good tree map will have distinct numerical values, a distinct hierarchy, no more than 3 or 4 labeled tiles, and obvious highest level of hierarchy, not display negative values. However, a poor tree map will look cluttered with too many categories and labels, have too many similar values. Great example of tree maps is the biggest box tells the viewer that the most of the rooms available are the entire rooms or apartments, while the second biggest box measures the number of private rooms available. This tree map only measures a few categories in relation to each other. The white borders indicate that all three measures make up a whole. The colors are distinct from each other. That's all for today. Thank you.